Have you heard about the latest visitor to our solar system? It's called 3I Atlas, also known as C2025N1 Atlas. It's a comet, but not just any comet. It's interstellar. That means it came from outside our solar system, traveling for billions of years before we ever noticed it. Spotted on July 1st, 2025, by the Atlas telescope in Chile. At the time, it was about 4.5 astronomical units from the Sun, roughly 670 million kilometers away. Even from that distance, astronomers could tell right away that something unusual was going on. The comet was moving on a hyperbolic trajectory, meaning it wasn't bound to the Sun at all. It wasn't looping around like the planets or even most comets. Instead, it was flying straight through, heading in and then right back out. Its speed alone makes it stand out. 3I Atlas is traveling at about 58 kilometers per second, or around 130,000 miles per hour relative to the Sun. That's much faster than the previous two interstellar visitors we've seen, Oumuamua in 2017 and Borisov in 2019. At this velocity, no gravity in our solar system is strong enough to capture it. Once it passes by, it will never return. Let's clear something up right away. 3I Atlas isn't going to hit Earth. Its closest approach will be about 1.8 astronomical unit from us. That's 270 million kilometers, safely farther than the distance from Earth to the Sun. So, while it's fascinating to study, there's no danger of collision. This comet is the third interstellar object ever confirmed, which is why it has the 3I designation. The first, Oumuamua, left us puzzled because it didn't behave like anything we'd seen before. The second, Borisov, looked more like a regular comet, with a tail and the expected outgassing. Now, with Atlas, we're building a clearer picture of just how diverse interstellar objects can be. What makes 3I Atlas intriguing is that it shows typical cometary activity, gas and dust streaming off as it warms near the Sun, but with some very unusual chemistry. Observations from telescopes like Hubble, James Webb, and the Very Large Telescope have shown that this comet is unusually rich in carbon dioxide, while only releasing small amounts of water vapor and carbon monoxide. It's also emitting cyanide gas and nickel vapor. Normally, comets contain nickel and iron in roughly equal amounts, but so far, no iron vapor has been detected here. That imbalance is strange and may hold clues about how this comet formed. About those three objects circling 3I Atlas, telescope frames often show extra points near a comet, but unless they co-move with the comet across multiple nights, they're background stars, noise, or structure in the coma, jets, clumps, and dust, not bound companions. As of now, no NASA ESA release or observatory paper confirms any objects gravitationally orbiting 3I Atlas. If that changes, the description and pinned comment will update with official links. Where did 3I Atlas come from? That's harder to answer. We can't trace it back to its original star because it's been wandering the galaxy for billions of years, nudged around by stellar encounters and galactic tides. But based on its motion, astronomers think it may have originated in the thick disk of the Milky Way, a population of older stars with lower amounts of heavy elements compared to our Sun. If that's correct, then this comet could be 7 billion years old or more, possibly older than the solar system itself. Imagine that. A piece of icy rock formed around a distant star before Earth even existed, now passing through our neighborhood. You might be wondering, how big is it? That's tricky to answer. Because comets have a coma, a surrounding cloud of gas and dust, it's difficult to measure the solid nucleus directly. Observations suggest the nucleus of 3I Atlas is small, probably less than a kilometer across, though it could be up to 5 kilometers at the upper limit. The coma, however, stretches tens of thousands of kilometers, and the carbon dioxide cloud detected by SphereX is even larger, hundreds of thousands of kilometers wide. High-resolution images from the Hubble Space Telescope in July 2025 revealed a faint tail pointing away from the Sun, along with a curious feature, a sun-facing plume. Instead of only ejecting dust away from the Sun, this comet was also releasing material directly toward it. That unusual geometry suggests localized jets on the comet's surface where ice is sublimating quickly. 3I Atlas will come closest to the Sun on October 29, 2025, at a distance of 1.36 astronomical unit between Earth and Mars. Before that, it will pass closest to Mars on October 3rd, at about 28 million kilometers away. After perihelion, it will swing past Venus on November 3rd, about 97 million kilometers away, and then past Earth on December 19th at 270 million kilometers. Finally, in March 2026, it will pass relatively close to Jupiter before continuing on into deep space. Its orbit is highly hyperbolic, with an eccentricity over 6, much higher than any bound orbit in the solar system. In practical terms, this means its path is almost straight compared to the looping ellipses of planets. Despite the excitement, don't expect to see 3I Atlas with your own eyes. At its brightest, it's predicted to reach magnitude 11 or 12, far too dim for the naked eye. Even binoculars won't be enough. You'd need at least a medium-sized telescope under very dark skies. For most of us, the only way to see it will be through images taken by observatories. The comet has been studied by nearly every major telescope available. Hubble has imaged its coma and tail in detail. The James Webb Space Telescope has measured its composition, detecting strong carbon dioxide emissions, along with smaller amounts of water, carbon monoxide, and carbonyl sulfide. Spherics and ground-based telescopes have confirmed these findings. The fact that the comet is so rich in carbon dioxide is unusual. Compared to water, the ratio of CO2 is extremely high, about 8 times more abundant. That's far outside the typical range for comets in our solar system. It suggests either that 3I Atlas formed in a very cold region, far from its parent star, or that radiation over billions of years has altered its surface chemistry. Either way, it challenges our assumptions about how comets are built. There are 3 things truly circling this story. 3 close encounters, Mars, Venus, Earth's neighborhood. 3 flagship observatories, Hubble, JWST, VLT, and 3 chemical surprises, CO2 dominance, nickel without iron cyanide. Let's break those down next. Like most comets, 3I Atlas is irregularly shaped and spins as it travels. Studies suggest a rotation period of around 16 hours, although it's hard to pin down exactly because the dusty coma hides brightness variations. As it gets closer to the Sun, its activity should increase. Jets of gas and dust may burst out, and there's even a chance of fragmentation, like what happened with Comet Borisov. So far, though, 3I Atlas seems steady. Unfortunately, no. By the time we discovered 3I Atlas in July 2025, it was already too late to send a spacecraft from Earth. The required velocity change would be far beyond what our rockets can achieve. If we had known about it earlier, a probe from Earth or Mars might have been possible, but now, all we can do is observe from a distance. That said, some existing spacecraft might get a view. The JUICE mission, headed for Jupiter, may attempt to observe 3I Atlas when it passes nearby in November 2025. The Juno spacecraft might also detect it in March 2026 when the comet swings past Jupiter's orbit, though Juno's fuel limitations make that unlikely. Even the Psyche spacecraft will pass within about 45 million kilometers. None of these craft were designed for comet encounters, but astronomers will try to squeeze in observations if possible. No cosmic discovery would be complete without some bold speculation. Some researchers, like Avi Loeb, have raised the possibility that 3I Atlas could be artificial, a probe or spacecraft built by another civilization. This idea stems from its unusual trajectory alignment and chemical makeup. However, most astronomers strongly disagree. The evidence points to 3I Atlas being a natural comet, displaying the expected features of outgassing, dust tails, and a volatile, rich composition. The broader scientific community is cautious about extraordinary claims. For most researchers, the real excitement lies in understanding what this comet can teach us about the conditions around other stars. Even if it's natural, it's still the oldest and most exotic comet we've ever studied. Studying 3I Atlas isn't just about curiosity. Interstellar comets carry information about how planetary systems form. By comparing their chemistry with that of comets in our own solar system, we can learn whether the building blocks of planets, and maybe even life, are similar across the galaxy or highly variable. For example, the high levels of carbon dioxide in 3I Atlas may indicate a very different kind of protoplanetary environment. It suggests that other planetary systems might have very different volatile balances, which could affect habitability. In just 8 years, we've gone from knowing of 0 interstellar visitors to 3. This suggests they're far more common than we realized. As our telescopes improve, especially with projects like the Vera Rubin Observatory, we may soon detect dozens more. Each one will bring new puzzles and new data, slowly painting a picture of how the galaxy recycles material between stars. My atlas may not be visible to us in the night sky, but for scientists, it's already a treasure trove of information. It's a reminder that our solar system isn't isolated. We're part of a much larger galactic ecosystem where icy fragments wander between stars. So, what do we make of this visitor? 3I Atlas is a natural comet, but an unusual one. It's old, possibly older than our solar system. It's fast, faster than anything we've seen of its kind. And it's carrying a chemical signature that doesn't fit neatly into our categories. Over the next year, astronomers will watch it closely, gathering as much data as possible before it disappears forever into interstellar space. Once it's gone, we'll be left with the records, spectra, images, and maybe even new questions we hadn't thought to ask. The bottom line, this isn't science fiction, it's science unfolding in real time. An ancient traveler from another star system is passing through our neighborhood, and for a brief moment in history, we get to watch. If you enjoyed this deep dive and want to join us on our journey to explore the biggest questions in the universe, please take a moment to subscribe. It helps our channel grow and ensures you won't miss what's coming next. Thank you for watching.